Alright, so this is a video on dividing square roots. And really, it's exactly what it sounds like. We're going to split it into two components. We're going to divide, and then we're going to break down square roots. So there's two ways your problems can look. The first way is they can look like division with a division sign, like that. Oh, skipped too far. Like that. So something like maybe the square root of 36 divided by the square root of 3. That could be the first type of problem we see, where we have two radicals, two square roots, and then a division sign between them. Now, the second way is it could look like a fraction, and that fraction bar is acting like the division sign. So that same problem we used up top, it would look like this. And these mean the exact same thing. We're going to do about the same process on both. We're going to divide and then break down the root. They just look different. So just know that they're doing the same thing. We're going to start with way number one with a division sign. We got two examples here. Our directions say to divide the two radicals, and we want to always give that radical in the simplest form. So our first problem here is the square root of 80 divided by the square root of 2. So we have two radicals and that division sign. We're going to look at the radicands. We're just going to divide 80 by 2. 80 divided by 2 is 40. And we're going to put a square root on it, and we're going to break down 40, the square root of 40, which we have already learned how to do. Well, 40 is really 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So I get 2, 2, 2, and 5. I'm making a perfect square out of those first two twos. And that's 4, and the square root of 4 is 2. These two numbers do not make a perfect square, so I multiply them back together, and I get 10. So our answer to this problem, the square root of 80 divided by the square root of 2, is 2 square root 10. And I want to show you again, we broke it down into two components. We divided the radicands first, and then we broke it down, broke the square root down. Okay? We're going to do the same thing on the second one here, the square root of 72 divided by the square root of 3. So 72 divided by 3. Look at the radicands first. Well, 72 divided by 3 is 24. And we're going to take the square root of 24. 24 is really 8 and 3. And 8 becomes 4 and 2. 4 becomes 2 and 2. So we have 2, 2, 2, and 3. Making that perfect square out of those 2's gives us 2 square root 6. And 6 because the 2 and the 3 get multiplied back together. So that's our answer, 2 square root 6. Pretty simple here. You have two radicals, and they have the division sign between them. Again, break it down into the division first, divide the radicands, and then break that radical down from the answer you get from the division you did. Okay. Second way, they're going to look as a fraction, but we do it the same way, the same process. We look at our radicands here. So our first problem is the square root of 75 divided by square root of 5. Well, 75 divided by 5 is 15, and we're going to put that underneath the square root and try to simplify it. 15 is really 5 and 3. I can't do anything with that 5 and 3. I don't make a perfect square. They don't pair up, so they get multiplied back together, and our answer here is the square root of 15, and that one's done. So sometimes they don't simplify. Same process here on our second one. Look at those radicands. 120 divided by 5. Well, that's really 24, and that should look familiar. That was the 20. It's the same 24. It's going to break down the same way from our second example on the other slide. I am going to break it down in a different way this time. I'm going to do 4 and 6, and 4 is 2 and 2, and 6 is 2 and 3. And the only reason I'm doing this is to show you that it doesn't matter how you break down the radical, you're going to get the same prime factors here, number components, when you try to make your perfect squares. So 2 and 2 make 4. 4 square root of 4 is 2. And then the 2 and 3 here don't pair up, and we get the 6 again. So again, the same answer, 2 square root 6. Alright, so that's how we do these. That's how we divide radicals. It does get more complicated. All of these, the numerator has a bigger radicand than the denominator. If we have a bigger radicand than the denominator, we do something else, which is what we're learning tomorrow. So we're going to start with these easy ones. Make sure you can do that, and then we're going to ramp it up a little bit for tomorrow. If you have any questions, please be sure to let me know. You have a short homework assignment over this.